Welcome to the Automation Technologies RS Logix 500 training series. This is Russell White, and I'll be leading you through some short examples on programming in this platform.
Alright, let's talk about shift registers. Shift registers in the SLC 500 are handled with two commands. You have a bit shift left BSL command and a bit shift right BSR command, and they're kind of self-explanatory. You've got to shift the bit to the left, use the BSL, and you shift the bit to the right, you want to use the BSR. Let's go a little bit into the components of the instruction now. Alright, the bit shift register works in this way. When you have a false to true transition, the bit either shifts to the left if you're using a BSL or to the right if you're using a BSR. You have ways of loading data into your bit array, and you have ways of unloading data from your bit array. Now, with that as an overview, let's look at the different components that are required of this. Obviously, you have to put your instruction in a rung, and it is on the action side of the rung. You have a file that actually is where your data is going to be. You have a control address, which is the information. I guess it keeps track of these enable and the done bits. It keeps track of the positions. It keeps track of the size of the array, this information down here. You have the bit address. That's the bit that's going to, you can either set it on or off to load either a 1 or a 0 into your bit array. And then, of course, at the end is a length of your bit array. Now, I've made it 16 bits because that's what a in-style register can hold, and that way it's just kind of easy for us to look at in this moment. It could be a wide variety of different values in there. One thing, though, if you use a partial word, it will only allow you to use, I guess in essence, it won't allow you to use the rest of that word for anything else. You have to use that word for your bit shift instruction array, and that's it. Looking further at the instruction, let's go down here and let's open up some of our data files here, and let's open up our integer file. This file right here, I'm going to change it over to a binary file so I can look at the bits a little bit better. So these 16 bits here, this is N7:0, and these 16 bits here are where our data is going to be shifted. Right now I've got a bit just sitting there in bit 5, and that right there we'll be able to watch a little better and see how that bit shifts around our program. Alright, let's look at this and see now how this really works. I'm going to slide this window down here so we can look at our registers a little bit better. In fact, when I click on it, it's not going to stay there where we can see it, so I'm just going to come up here. I guess it might be better to go online first. Let's go online with our processor. Now we're actually in a run mode. You can see that since we're online, we've got the green bars telling us that we're running. This also tells us that we're running. And now let's find that window again, our N7 window. Change it back to binary again, and let's watch our bit here. Now, bit shift left, we expect the bit to move this way. Bit shift right, we expect the bit to move this way. So I'm going to toggle my bit here. Now we've moved it one space over, toggle it back off. It only moves on a 0 to 1 transition of this input here. So toggle it on and toggle it off, and you see that it's moved 2 spaces to the right. Now same thing on the other way. Toggle it on, now it's moving to the right. Toggle it off. Whoops, missed the toggle. Toggle it off. Toggle it back on, and we're back in our original location. Alright, so that's the simple part of what this instruction really does. It's not fancy instruction. It is nice to allow you to toggle, I guess to have these instructions maybe track something. If you've got, say, 16 specific locations where something might be, and it might be moving down a line. Maybe you've got 16 slots, and you want, some of them may have something in them, some of them may not. So you want to be able to keep track of which one's full as it moves down a line. If you can do without it, obviously this is an instruction. I think I had to go and look back and remind myself how to use it. If you can do without it, don't just try to use it for the fun of it. The whole point of ladder logic, in my philosophy anyway, is to keep it as simple as possible. So if this instruction, being a little bit more complex than some of the other instructions, if you can do it another way that's simpler, do it another way that's simpler. And that's the important thing here. Alright, now let's talk about these bits right here. What's this bit address do? Okay, that bit address, I'm going to open up another file here. That's our B3 file. You see a B3, and open this up. It's B3, the very first word, which is :0, B3 :0, and then the very first bit. So that would be this bit right here. Alright, so what is different now when we have this bit set? Right now, you notice with our other examples, we've had that bit set to 0. Let's go ahead and toggle this bit. Now we've got this bit B3, in fact you can see it down here also, B3 :0/0, the same bit we have in here on our bit shift left command. And let's see if we can, I'm just going to go ahead and close that down. Go ahead and pull up our N7 file. Let's see what happens if we go ahead and toggle our bit this time. Now our bit here still moves to the left, but then we've also got a bit now that's a 1 right here. So what it's done is you can kind of think of that that bit that we just set as sitting over here to the right, and when we hit bit shift left, whatever value this has is what's going to shift in here. So now if I go ahead and toggle it back off again, toggle it on again. Now I've got another 1 in there. Now if I go in there, let's turn this bit off. Don't get confused with this bit down here. That's this bit right here. I'm going to go ahead and turn it off also. Now if I turn that off, open up our integer file again, toggle this back on, now that 0 is transferring in there. So that's how that works, and it works the same way on the other side of our instruction. Obviously right now we can shift this right. There's just not enough room up here with these small windows I've got to use for internet. If I toggle this bit on and toggle it back off, I really should go ahead and toggle this off. It didn't affect anything, but it's just a good practice. So I'll go ahead and toggle that on, toggle it off. You see now our bit has kind of jumped off the side. So now if we go ahead and shift it left again, notice that it doesn't come back on again. It all depends on the bit right here, what's going to be loaded in here. It doesn't mean that since you dropped a 1 off, it's going to have a 1 come back on the next time you do it. So now if we go to our other side, let's go ahead and, I guess I need to open up my binary file again, toggle this bit. That's the /1 that we're using in the bit shift right. Go ahead and close that down. And now I'm gonna look at the left side of this. It's kind of hard with 16 bits. Maybe I should have used 8 bits or something for my example since I'm with limited space, but I didn't. So I'm going to go ahead and toggle this on, toggle it off, toggle it on, toggle it off. Now you notice that those bits, the 1s, are being shifted in here from the left side as we shift all of these bits to the right. So that's in essence what a bit shift register does. That's how you can shift data into it, and that's a little bit about how you can set it up. You notice both of these, this file has to be the same. I'm working on the same N7:0, the same 16 bits of data. Now the control word, notice those are different. That's separate. These enable bits and done bits and all the control words that make up these two instructions have to be separate and have to be independent.